Hello there, welcome to Umid Private High School online class. In this class we are starting a new chapter that is a last chapter of 9th grade physics. Okay, before starting the chapter I want to explain these two figures just as a warm-up. Left side here you see one object is attached to one spring balance, and spring balance is showing the weight of this object as 12 Newton. You see, and if we place this object inside the liquid, now this spring balance is showing a different number, a different weight. You see, now it is 8, previously it was 12. Now why it decreases? Because you see, dear students, this object is inside the liquid, then liquid applies one upward force from here. Okay, from here one upward force is acting on this object. If upward force is acting, then weight obviously decreases, and you see some of the liquid has displaced into this graduated cylinder, and the weight of this liquid also 4 Newton. It means this upward force is equal to 4 Newton. Because how do we know? Here weight has decreased by 4. Now let's come to this figure. Here you see one ship is there on the water, and why it doesn't sink? You know, ships have lots of weight and they do not sink. Why? You see, weight is downward, it should sink, but it does not sink because here another upward force is here. You see, upward force balances this weight. That's why ships do not sink. And this upward force has a special name, that is, you see, upthrust. Now let's get started our chapter. Buoyancy or upthrust force. In Pashto, buoyancy means su'udi quwa. Su'udi quwa means upward force. Now let's understand this buoyancy or su'udi quwa in more detail. You see, the force acting on an object inside a liquid by that liquid is called upthrust force or buoyancy. You see, upthrust force or buoyancy. We can say upthrust force, buoyancy, or buoyant force. Okay, this force basically, you see, this force has different names. What kind of names? Upthrust, buoyancy, or buoyant force. Okay, basically this is a force which is applied by a liquid on an object inside that liquid. Okay, now let's put this object inside this liquid. What will happen? Okay, now here you see, if you throw this into this liquid, then this liquid applies force from all directions. You see, it applies this kind of force. Now these forces are known as buoyancy, but side forces cancel each other. Okay, side forces cancel each other, and all these forces will be cancelled with some of these forces. Only some of these forces will be left. Now this force is basically known as buoyant force. Okay, now let's continue. Archimedes principle. Okay, Archimedes principle gives information about different methods of calculating upthrust force. You see, this upthrust force, how we can calculate it. See, if we throw this object, you see, before throwing, its weight is 100 Newton in air. In air it is 100 Newton. Now let's throw it into liquid. Now it is 80 Newton in water. Inside water, weight is 80 Newton, and some of the liquid has displaced here. Okay, it means a weight of the object has decreased. Now this weight is basically actual weight, asli wazn, and the weight of the object inside the water is apparent weight. Now Archimedes says that this upthrust force which is acting on the object, from here we have upthrust force, right? Here we have upthrust force. Now this upthrust force will be equal to actual weight minus apparent weight. Okay, this way we calculate this upthrust force or buoyancy with the help of this formula. Upthrust force is equal to actual weight minus apparent weight. This is first point in Archimedes principle. Okay, now let's continue. Here you see we in air 100 Newton, in water it is 80 Newton, weight of displaced liquid also 20 Newton. Now upthrust force is equal to actual weight minus apparent weight. It means 100 minus 80. See, 100 minus 80 becomes 20. So 20 Newton force is acting on this object from this side. 20 Newton. Okay. And one short note is there. Upthrust is measured by the dynamometer. Yes, obviously upthrust is force and force is measured by spring balance or dynamometer. What about volume of the object? What Archimedes says about the volume of object? Archimedes says that volume of this object is equal to the volume of displaced liquid. Okay, volume of this object is equal to the volume of displaced liquid. This is another important point related to Archimedes principle. See, volume of object in liquid is equal to volume of displaced liquid equal to immersed volume. Okay, now next important point, you see here, according to Archimedes principle, the weight of the displaced liquid is equal to buoyant force. Okay, this is another very interesting and important point related to Archimedes principle. Okay, Archimedes says that upthrust force or buoyant force is equal to the weight of displaced liquid. Okay, how much force is acting on this object will be equal to the weight of this displaced liquid. Okay, let's write that. Here you see, you know weight is equal to m times g, right? And from density formula, you know mass is equal to volume into density, right? Volume into density. Now, if we write volume into density instead of mass, what we will get? We get this formula. Okay, we get this formula. For weight is equal to volume into density into g, right? Now, this is basically buoyant force. You see here, upthrust force is equal to weight of displaced liquid, and weight of displaced liquid is what? You see here, V into D into G. You see, immersed volume or volume of displaced liquid or volume of object itself. Any of them we can take. Density of liquid into G. This is second formula of buoyancy or upthrust force, which is derived from Archimedes principle. Okay, we can derive another important formula. You see here, upthrust force is equal to weight of liquid displaced. Now you see, you know weight is m times g, right? And upthrust force, this is upthrust force, right? And the upthrust force's formula, this is the formula of upthrust force. We immerse the liquid, G is equal to m times G. Okay, now see, G gets cancelled. What is remaining things? Mass is left here, V into D left here. Okay, we know mass is equal to what? Mass is equal to density into volume. If we write density into volume here instead of m, then finally we will get this formula. This formula also important. Okay, let's solve some examples. Example 15. A block of metal has a volume of 0.09 meter cube. Calculate the upthrust force when it is completely immersed in brine. Okay. See, they are asking what? Upthrust force. And they have given density and volume they have given. Okay. Here, using Archimedes principle, we have a formula for upthrust force. Formula is upthrust force is equal to density of liquid into volume of displaced liquid into G. Okay, here density of liquid, as you see here, it is how much? 1200 kilogram by meter cube into volume of displaced liquid is equal to the volume of immersed object, that is 0.09 meter cube into 10 Newton per kilogram. Okay, Newton per kilogram. Here kilogram disappears, meter cube cancel. The remaining terms will be upthrust force is equal to, if you multiply this, how much it is? Okay, it's 1080 Newton. Okay, this is how we calculate upthrust force. Example number 16. An iron box of mass 90 gram and density 0.9 gram by centimeter cube floats on a liquid. What is the volume immersed in the liquid? Okay, you see, one object is there floating like this. They are asking this immersed volume. Immersed volume is the volume which is inside the liquid. Okay, here we need to calculate this volume. We have one formula from Archimedes principle. You remember this formula? Okay, we use here this formula. So density of object into volume of object is equal to density of liquid into volume of liquid, immersed liquid, displaced liquid. Okay, here density of object is given, volume of object is not given, but instead of volume of object, can we write density of object into mass of object divided by density of object? Can we write volume? Yes, it is volume equal to density of liquid into volume of liquid. See this one? Volume is equal to mass divided by density. Okay, density from density formula. Okay, from here density of object cancel. Mass of object is how much? You see, mass of object is 90 gram is equal to density of liquid is 1200, means 1.2 gram by centimeter cube into density of displaced liquid, volume of displaced liquid. Okay, from here you see common factors get cancelled, gram disappears. Next, 90 centimeter cube divided by 1.2 is equal to volume of displaced liquid, should be equal to volume of immersed portion of the object. From here, volume of displaced liquid is equal to V immersed equal to how much? 90 divided by it is 75 centimeter cube. This is how we calculate the volume. Example number 17. What fraction of a wooden cube of side 10 cm will be below this water surface? Okay. If the cube is floating in the water, again floating case. So you see, one cube is given. Each side is 10 centimeter. Okay, 10 centimeter, 10 centimeter. Total volume will be how much? Volume will be 10 into 10 into 10 means 1000 centimeter cube. Okay, again using the formula of the object into the object is equal to density of liquid into density of immersed portion or density of displaced liquid. Okay, from here density of object is given 0.6 gram by centimeter cube into volume of object is how much? This 1000, right? 1000 centimeter cube is equal to density of liquid is 1 gram by centimeter cube into this. This is volume, right? This is volume. You remember the formula? This formula? Okay. Into V immerse. Okay, you see, they are cancelled. Gram by centimeter cube, gram by centimeter cube cancelled. 0.6 into 1000 is how much? 600 centimeter cube. This 600 centimeter cube is equal to V immerse. Okay. So if immersed portion is 600, total volume was 1000. So fraction will be V immerse divided by V object is equal to 600 divided by 1000 is equal to 3 divided by 5.